This 0 here counts in sig figs because it is between two non-zero numbers. So to round this off to 3 significant digits is going to be 67.0. So that counts. This one counts, but this one does not because it's just a placeholder. So if you're rounding this one to 3, it's going to be 0.0150 because this 0 counts at the end because you're measuring out that far. And then this is going to go to 106. Calculating significant digits in multiplication problems, you always go to the least accurate. So you got 4.50 times 2, and so that's going to be 9.0 because it has 1 decimal point in the second part. All right. Dividing's the same way. On part C here, there is no decimal after here, so you only can round off to the before the decimal point. And then on adding and subtracting, you got 9.15, you got 2.1, and you got 4.72. And you only can be as accurate as your least accurate. So you only got 2 sig figs here, and that's all your answer can be to. So you got 7, 9, and what do we got here? 15. And so this would round off to 16 right there. I'll let you do 10 on your own. Like I said, I'm posting the key later today. Do you need to do conversions? Okay, let's scroll past here. Everybody know how to do density? That will be an equation given to you. What's the density equation? Mass over volume. Now, everybody pull out a periodic table in front of you someplace there. Should be a whole stack with all the solubility rules and all that kind of stuff. So on Thursday for the test, all the equations will be on the board, but there'll be a periodic table, a sig fig card, and activity series and solubility rules for you. Now, iron. How many? We got protons equals neutrons equals and electrons. This should be a plus. Here we go. So, where do we find the number of protons in iron? Atomic number, which is 26. And since this is a neutral atom, how many electrons does it have? 26. Your pluses equal your minuses. And now how do we figure out neutrons? Yep, this number right here is your mass number. And so mass number is protons plus neutrons. So 65 minus 26 is, what is it? 39. So that's how you do that. All right. I'll let you do calcium on your own. Complete the following chart. This one gave a few of you some fits. So, when it's written uranium dash something, it is the mass number. So the mass number for uranium-235 is 235. What's the number of protons in uranium? 92. Do you see a charge over here? Nope. So how many electrons? 92. And how many neutrons? What? 143? He did the subtraction. Now, the symbol notation is U, mass number on top, 235, atomic number on the bottom. Who can I pick on here? Who can I pick on? How about, should I pick on Bayes? Since he's not listening. So, Bayes, what element has an atomic number of 1?
Bayes. What element has an atomic number of 1? Oh, you're talking to me? Your name is Bayes, right?
Did he give an answer yet there, Tyler?
No, hydrogen.
Hydrogen, all right. Hydrogen. All right. Now, what goes after the little dash here? Anybody? The mass number, which is 2. All right. How many protons in hydrogen? 1. How many electrons? 1. Neutrons, if a mass number of 2, so it's 1. So it's H2 over 1. What is C? Carbon. What's the mass number for carbon? Or this one? 12. Atomic number? 6. 12. Protons? 6. Electrons? And neutrons? 6. Uh-oh. I didn't make this up. But some of you think chemistry is the devil anyhow, so. All righty. Now, I'm going to thin up the line here. Says lead has 4 naturally occurring isotopes. The first occurs at 1.48% of the time and has a mass of 204 AMUs. So, to do atomic mass, you're going to take the percentage times the atomic mass of each isotope. So, the first is going to be 204 times what? 0.0148, because you have to convert the percentages to decimals. Then, says the second one occurs at 23.6 and has a mass of 206 times 0.236. The third is 207 times 0.226. Okay. And then the last, the remainder, the fourth, occurs the remainder of the time and has a mass of 208. But what didn't they give you? The percentage. Can we figure it out? How can you figure it out? Right, take all the other percents and add them up and subtract from 100. Did anybody do that? What'd you get? 52 point what? 32. So, now when you do all that math, remember, do the parentheses, each quantity in there, then add them all up. If you have a fancy calculator, you can put everything in parentheses, and yes, you can use a calculator on the exam. Haley, I'm recording it, so whatever you missed, it'll be posted after class. Yep. I don't know if they can hear you talking. They can hear me talking to Bays when he didn't listen. All right, let's keep going here. I'm only going to do one each of these examples here. And so it says, convert 10 grams of SiO2 to moles. So we start with 10 grams SiO2, and then I want to get it to moles. And 1 mole of SiO2 weighs how many grams? So you have to figure out the molar mass of SiO2. Now, so we're going to go Si and O. How many SIs do I have? How much does it weigh? Look on your periodic table. It's the
23.
Is it, what's it say, 22 point what?
This is 28.0855.
So we'll just call it 28. All right. How many oxygens do we have? 2. How much do each oxygen weigh? 16. So we got 28 plus 32 equals.
No. Plus it? Oh, 50. No, 61.
60. So now, guys, it's going to be 10 times 1 divided by 60. You always divide when it's on the bottom. So it's 10 times 1 divided by 60. You don't have to do the 10 times 1 part. So you're just dividing by 60. So what's 10 divided by 60? Somebody got that? 0.166 moles. All right. Whoa, what happened? There we go. So you have, from grams to moles, divide by the molar mass. You have to figure out the molar mass. And yes, there is going to be a few of these on there. Let's see, conversions. There's at least 3 questions about conversions on there.
How many questions?
There's 50 multiple choice and 6 written with parts. You get an hour and a half. Now, moles to atoms. Moles to atoms. So, let me change colors. Let's go with black. So, we got 6.3 moles. How do I get to atoms? In 1 mole, how many atoms are there? It's a really, really big number that you should have memorized a long, long time. 6.02 times 10 to the 23rd atoms. Now, the easiest way to figure this out is take the 6.3 times the 6.02, and I get 37.926 times 10 to the 23rd. Is that in the right format? I have to move the decimal which direction? left. So that increases the exponent 1 time. So there is the correct answer. And the last conversion here is moles to mass. So I got 5 moles of K. And when we went grams to moles, we divided. So going moles to grams, we're going to multiply. How much does K weigh? Potassium, 39. And 5 times 39 is about 195, something like that. Is that right? Probably. You're going to take my word for it. 195 grams. All I did was take 5 times 9 and 5 times 30. All right. You don't have to worry about 22 and 23. What is an orbital? Energy level. What lives there? Electrons. What are the 4 types of orbitals? Letters. S, P, D, and F. Now, if you look down the side of the periodic table, there should be numbers, or you can count. Hydrogen's the first energy level, second is lithium, third is sodium, that row. So you just count down the side, 1, 2, 3, 4, 5, 6, 7. And the questions on the test could be, what is the highest energy level that iron has? So you count down the rows, and what row is it in? What row is iron in? Count down the rows. Horizontal rows. What row is 4? So its highest energy level is 4. It's that simple, the question would be. So what's the highest energy level gold has? 6. All right. So not difficult. Or chlorine. Yep. You use the black and white one. Nope. Because you should have most of that stuff memorized. Plus silicon on there has got the silicon and bromine have the wrong atomic weights. So somebody in the front row that's playing with their phone, tell me what the highest energy level of oxygen is. 2. Very good. All right. Now, which energy level is closest to the nucleus? This seems like, no, energy level, and then we're going to do orbital. Energy level are numbers. Good point here. Energy levels are numbers. Those are the 1, 2, 3, 4, 5, 6, 7 down the side. So, which energy level is closest to the nucleus? 1. How many which main energy level has the lowest energy that doesn't make sense, but it's the S. All right. That's a weird question there. Fill in the following chart. How many orbitals in the first energy level? 1. What's the shape? Give me a letter. It's a sphere, circle. All righty. All right. Oh, they don't want a shape there. They want a letter in there. So the orbital shape is an S. Number of orientations, 1, because you only can have one orientation in a sphere. And the number of electrons in an S, 2. In the second energy level, there is 2. An S and a, what's the next energy or orbital? P. Number of orientations is 1. The p orbital looks like this. And then it has a third one that comes out like this. So you got a z-axis, you got a x-axis, and you have a y-axis. How many? So you got 3 shapes. And each shape can hold how many electrons? So there's 2 here, so in the P a total of 6. And the third energy level. 3 orbitals, S, P, D, and it's 1, 3. It might be easier to work backwards. S's always have 2. P's always have 6. How many do D's have? It's the same number of transition metals across. Nope. Count the transition metals. Physically count them. 10. So, if the S has 1 shape and has 2 orbitals or 2 electrons, the P has 3 shapes and has 6. How many shapes does the D have? 5. Anybody remember how many F holds? You're close. Count the bottom. Count the bottom row. Leaving off lack 14. So how many shapes? 7. Okay, here's that question I just asked. What's the highest energy level for barium? Where's barium? 6. Chlorine. 3. Bismuth. Where is bismuth? 6. What's the symbol for bismuth? Bi. Now, write the electron configuration notation for magnesium. Now, we're going to go out here. I'm just going to do magnesium. What's the atomic number for magnesium? 12. So we got to come up with 12 electrons. So we start with the 1s. How many does it get? 2. There is no 1p, so we start over. 2s. 2. 2p. 6. What's our total so far here? How many superscripts do we have? 2, 2, and 6. What's that add up to? So, and what energy level is magnesium in? 3rd. And it's in the S, and that's what it looks like. So, I'm going to step away. second here. So remember this. Here's how it goes. Look on the periodic table here. First energy level, and it has S. 1, 2. Second energy level, S2, P, 6, 3S, 3P, 4S. Remember, the D's are one behind. 3D, 4P. All right? And so, this is your S block, only can hold 2. This is your P block, can only hold 6. Your D block can hold 10. They won't give you anything down here, but this is the F block and it can hold 14. So, let's go through a couple more of these. Let's do manganese. Let's change color. Manganese, what's its atomic number? Manganese. 25. So you got to come up with 25 in the end. So we're going to do 1s2, 2s2, 2p6, 3s2, manganese, then we got 3p6 because we keep going over and then we hit return and go to 4th energy level. And then we're back to the 3D. How many elements over is manganese in the D? 1, 2, 3, 4, 5. Now, do all these superscripts add up to the atomic number for manganese? 2, 4, 10, 12, 18, 25. Now, key point here, electron configuration. That is without the noble gas configuration. Now, noble gas configuration changes things. It shortens things up for you. So we'll do barium here. What is the noble gas before barium on the periodic table? Xenon, so you can put in brackets Xe. That eliminates a lot of S's and P's and D's. What energy level is barium in? 6. What block? S. Which position? 2. Right there. And let me change colors and we'll do germanium. So germanium, I'm going to go way over here. What is the noble gas before germanium? Argon. Going down to the next line, what energy level are we in? 4. Is it filled up, the S? Yes. And to get to germanium, we have to go through the 3D. Do we go totally through the 3D? So that adds 10, which brings us back to the 4P, and what, I don't know why this isn't working. P2, good job, Bays, second position. Now, orbital notation is different. This is with the arrows. So let's do calcium. So calcium's way down, so we're going to do this. We're going to have 1s, 2s, two p. This gets really complicated. Whoops. 3s, three p, and 4s. Now, orbital notation, what little symbol do we use? Arrows. Up and down arrows. And because calcium is all the way down, we fill in everything like this. And do we fill in both 4s's? Because it's in the second position. Well, I know some of you that actually study and have paid attention will not have a problem. Huh? You should be able to squeak that out. All right. Now, let's keep going. Bromine, highest energy level. 4. How many outer valence electrons are there? It needs 8. Where's bromine? So it has 7 because it's 1 away from the... What block is it on the periodic table? I just went through the blocks. The P block. Mm-hmm.
So number 29 can like skip a bunch of them.
Yep, 29's, well, wait, 29, yes, you can do the noble gas. So that's the key. It says
Number 30, right?
30 you can't, no. And then if it says orbital notation, you got to do the whole thing. If it says noble gas notation, you can shorten it up. But I think on the test, they're not these big long things that you got to write forever. Okay, guys. Now, what's the last orbital shape to be filled with electrons? That was a D because you had to go across the D to get to the P's, and the D was totally filled up. How many total electrons are there in bromine? There is a number on your table that will help you with that. 35, because it's a neutral atom. All right, here we go. All right. Put the following elements in order of increasing atomic radius. So, as you go left to right, they get bigger. All right, left to right, they get bigger. So it's going to be sodium. Oh, wait a minute. Sorry. Right to left, they get bigger. I knew that wasn't right. right to left, they get bigger. So argon is the smallest, sulfur next, phosphorus, and sodium. Because remember, the more negatives they have, the tighter they pull together. And as you get over, there's more electrons, so they pull tighter. Now, electronegativity and ionization energy are the same. Ionization, electronegativity, and ionization energy, they move in the same direction. They move the opposite of atomic radius. Remember that from way back. So, increasing ionization energy and electronegativity, it moves left to right. So let's draw a little periodic table up here. Atomic radius increases right to left and down. All right. Electronegativity and ionization energy go hand in hand, and they increase left to right and up. All right, already? Man, time flies when you're having fun. Okay, 34. This is something I can't help you with. You just have to know where the alkali metals are. Where are they? First what? Row or column? Column. Where's the alkaline metals? Second column. Where's the D block? They're the transition. Where's the halogens? Next to the noble gases, which are where? Far right. Where's the lanthanides and the actinides? On the bottom. All right, two types of bonds. Why didn't my pen? Well, this thing froze. Okay, types of bonds are covalent and ionic, and you determine whether they're polar or nonpolar, which means they are purely positive or negative, or both have no charge, by doing subtractions. And my computer froze here. So, for potassium iodine, take 2.66 minus 0.82. What do you get? Anybody? You get 1.84, so it makes it ionic. Iodine and nitrogen, 3.04 minus 2.66. 0.38, what's that make it? Polar. So this is how a question will look on the test. All right, you'll get the little thing here that tells you how to identify them. What are the 7 diatomic atoms? Right. And how do you write them when they are alone in a formula equation? How do you write them when they are alone in an equation? How do you show hydrogen gas? H2. How do you show oxygen gas? Fluorine gas. And iodine. I2. All right. And I'm going to stop. The whole computer froze up. All righty then. So I'm going to switch over to the packets here. All right. So I had to switch computers because the other one locked up. So we are down to number. Vesper. Now, this is for the modeling and things like that. I would put that on your, and how to do a Lewis structure on your card. Those are the two important things you need to put on your card. All right, Vespers and Lewis structures. I will be slightly lenient on those, but if you got them on your card, you should not mix them up. Now, where's group 13? Where's group 13 up here on your periodic table? Boron group. What's its normal everyday charge? Plus 3. That's what you put there. Group 15. Nitrogen. Minus 3. Group 17. Halogen. Minus 1. All right. On 49, what is it? That's weird. I was on 49, 50, 41. I will put Lewis structures and I have to draw those out, so I will put those out, post those for you tonight. All right. All right. Here's where we have some problems. And on the sheet that I put out last night, I said this is non-negotiable. You have to know the Pauli account. No way around it. Right? All right. KOH, give me a name. Potassium. I don't think I heard the right word. Hydroxide. Let's skip the E here. Don't complicate it. Very good. Iron 3 oxide. Because what she saw here is we had 2 irons, we had 3 oxygens. What's the charge on oxygen all the time? -2. So we got -6, we have to have +6. So it has to be on 3. Now, G. Sulfur. She is correct. Deca. Fluoride. And you have to know the acids. H2SO4 and HF. Sulfuric. HF. Hydro, because it's a binary. Fluoric acid. All right. Sulfur dioxide. I'm going to go to 43 here real quick. Sulfur dioxide. Yep. With sulfur. How many we got? 1. Dioxide. O2. Iron 2 sulfate. So, iron 2. What's sulfate in the charge? SO4 minus 2. So, how do we write iron 2 sulfate? FeSO4. Potassium permanganate is KMNO4. Nitrogen dioxide, NO2. Phosphorus trichloride, PO3 and sodium phosphate. Ooh. Na is sodium, plus 1 charge. Phosphate, PO4 minus 3 charge. How's it gonna look? Na3PO4. Now, on that thing I posted, yep.
Why is trichloride PO3?
Oh, sorry, I was going too fast, trying to get through all these. CO3. Now, some of you do this, and it's wrong, and I put that on the sheet. I put a lot of stuff up last night. Do not put parentheses around a single element. Don't need them. Alright, I saw that a lot on your balancing thing. Only thing you need parentheses are around when you have more than one polyatomic. You don't have to put a parentheses around that because there's only one of them. Alright, let's scroll up. Again, the key will be posted. Five types of chemical reactions. You have to know the generics on these, the 5 types of kinetic reactions. We just did this. Synthesis, double, decomposition, single, and combustion. All right, type of reaction. Combustion. Type of reaction. Double. Now, a couple of key things. Double replacement reactions will always happen. Don't put an NR next to a double replacement. The only thing you use the activity series for are the single replacement. Now, so, you have to balance these. This is supposed to be an arrow. I don't know why it's so small. All right. If you have an even number of carbons, you have to double it right away. Otherwise, it screws this up over here. So, we double the carbons. We put an 8 here. We got 20 hydrogens, so a 10 goes here. 8 times 2 is what?
16.
Plus 10.
26.
What times 2 will give us 26?
12.
13. Alright. Copper, 1. Chlorine, 1. Potassium, 2 and 1. So, does that balance everything? Yes. Yeah, on the back. Now,
Slice my finger at work. Thanks, though.
40, guys, 47. What did I just say about double replacement reactions? They always happen. What do you use the activity series for? Single. Will barium replace hydrogen? Look on the activity series. Will barium replace? So, I said that the double replacement will happen. NH4 Br plus MgCl2. So we gotta put 2 here, 2 here, and you're done. Now, magnesium chloride, ammonium bromide, those are halogens. All chloride, bromides, and iodide salts are soluble except if they're mixed with silver, mercury, or lead. Do we have a precipitate here? No, because these are all soluble. Key thing, last night, when I was going through these things, here's what I saw next to water sometimes.
H2O. Water, H2O.
Is water soluble in water?
No.
There should never be an S next to water. Alright? Now, we said barium will replace hydrogen. So you got BaCl2 and H2. Remember, hydrogen is a diatomic. Will lead replace hydrogen? Will lead replace hydrogen? Is it above or below it on the activity series? It's above, so it will. I just put a 2 here, 2 here, and I'm good to go. Now, how do you figure out the activity series for halogens? Where can you find it? Periodic table. Will iodine replace bromine? No, because it's below it. NR. And then we said these will happen, so we got MgNO3 2 and calcium sulfate. Balanced or not? Go 1, 1, 1, 1, 1, 1, 2, 2. Now, is magnesium nitrate or calcium sulfate soluble? So we go up and look. All nitrates, chlorates, acetates, and perchlorates are soluble. So this is a liquid, aqueous. Sulfates, you go to the rules. And again, a lot of you just weren't reading the rules. All sulfates are soluble except if they're mixed with barium, calcium, strontium, mercury, and lead. Is that on the list? All sulfates are soluble unless they're mixed with column 2. This gets the S. Alright. I will post Lewis structures and best for models for you tonight. Glad you all paid attention. Tyler.
Who's better? This class here.
Other class.
I got one.
You got one?
Do it right now.
Well, it depends what you mean by better.